So in this lesson I'm covering the idea of how to factor polynomials, particularly polynomials that have complex roots. And as you're going to see in these problems, I'm going to propose a couple different ideas. So I hope you'll sort of see the value in both methods and sort of be ready to use either one of them. So first, just as a review question, and this is like an intermediate algebra long division question. How do we divide z cubed minus 7z squared plus 13z minus 3 by z minus 3? So we could certainly use long division. We could certainly use polynomial long division and just say, how many times does z minus 3 go into this thing? If you remember how to do polynomial long division, I would say pause the video, run through this real quick, make sure you can do it on your own. If you've forgotten, then tune in for this. Right? The first step is basically how many times does z go into z cubed? And the answer for that is z squared. So we can put z squared up here on top. Then we distribute that z squared down to both the z and the minus 3. So that ends up being z cubed minus 3z squared. Your next step is to subtract that whole line, and so the way that I do it is I'll actually change the sign of everything there and then combine. So these add up to 0. These two here give me negative 4z squared. Bring down your next term, so plus 13z. And now we repeat the process. How many times does z go into negative 4z squared? It'll be negative 4z times. When I distribute that down, negative 4z squared plus 12z. Same thing as last time, change the sign of both of them. These add to 0. This gives me 1z. We bring this down. Z minus 3 goes into z minus 3 one time. And we find that when you divide this by this, you end up with z squared minus 4z plus 1. Wonderful, yay. That's how you divide. I will say, though, that there is an alternative method. There is another way to think about this. When you divide something, you are effectively saying that you recognize that z cubed minus 7z squared plus 13z minus 3 is equal to z minus 3 times something. And so sometimes it's actually easier to go about this problem by kind of like thinking your way through this. And some of you may not like this, but it's a valuable method to know about. I would argue you know what the first thing here is going to be. We know that this first term has to be z squared. And the reason is the only way I'm going to get z cubed is by doing z times z squared. Right? But now the next part. As you sort of imagine foiling this, you're going to get negative 3z squared, and I need to have negative 7z squared. So that actually tells you what this next term has to be. If I need to have negative 7z squared, and I already have negative 3z squared, this is going to have to give me negative 4z squared. That means this has to be negative 4z. Right? Then we move on to the next part, right? We recognize then, I'm going to pick another color to sort of continue this, these two things multiplied together are going to give me plus 12z. Well, I need to have plus 13z. So that means that whatever thing, like z times whatever this is, and I lost myself there for a second, this is giving me plus 12z, I need plus 13z, so this is going to have to be plus 1. So that gives me plus 1z from this, plus 12z for this, that gives me 13z for this. And then our final confirmation for the thing is that, if you did the last part of the FOIL, the negative 3 times the positive 1 would give me the negative 3 that I need for the end. That may not have been super duper clear, but the idea is this is a method. It can work, and there are some problems where this is actually a better suited method. So I'm probably going to do some of those as we go forward, so let's take a look at these examples. So, given that 4 minus I is a root of this polynomial, find all three roots of that polynomial. And I really hope you guys remember the one of the main points that I covered in the previous video. And I don't want to give any hints about that, but what's the first piece of information that you can extract from this problem? And I'll let you pause and think about that for a second. So you may have said that the first piece of information you can extract is that this root means that there's a factor of z minus 4 plus I. And I'll agree, that's an important piece of information, but there's one more important than that. So if you didn't come up with the other one, pause again and think about it. What else do you know about this polynomial? What else do you know about the roots and the factors? You should know that 4 plus I is another root, which means another factor is z minus 4 minus I. Right? And so the idea is if you know one root, one complex root, then you know another complex root, and if you know two complex roots, you have two complex factors. That means we know that both of these things divide into this. I just need to find the other thing that goes into it so I can find all three roots. So the way I'm going to do that is by multiplying z minus 4 plus I with z minus 4 minus I. And hopefully you remember the trick from the previous video that we can see this as a difference of squares and sort of foil this thing as z minus 4 squared minus I squared. This is going to give us z squared minus 8z plus 16 plus 1. So z squared minus 8z plus 17. So now I just need to know how many times does this go into this. And at this point you get your choice. I mean, we can do polynomial long division. We could do the trick that I showed before. So I'm going to go ahead and do long division on this one. That's how I'm going to set this one up. But I have to write this down so I can scroll down. So that was that polynomial. So what I need to look at is how many times does z squared minus 8z plus 17 go into z cubed minus 7z squared plus 9z plus 17. So z squared goes into z cubed z times. If I distribute this thing down to all of these, I'm going to end up with z cubed minus 8z squared plus 17z. Then we change all of the signs. Adds up to 0, adds up to z squared, adds up to 8z, and we have plus 17. This goes in plus 1 time, and when we bring these down, you can see that all these things are going to cancel out. When I go through and change all these signs, this is going to add up to 0. So this thing went in that many times. The last thing we need to do is we need to answer the question. The question asked, what are all of the roots? Right, and hopefully the question will still be back up here. The question was, what are all three roots? Right, well, one of them is 4 minus I. One of them is 4 plus I. So we had 4 minus I, we had 4 plus I, and what's the last root? Well, my last factor was z plus 1. That means my last root is negative 1. Those are the three roots for this polynomial. Okay, let's look at the last example. So in this one, given that z plus 2 minus 2i is a factor of that polynomial, find all of the solutions. Note this time I'm asking for solutions, not for roots. Fair enough, it's actually the same thing, but different wording. We want to find all the solutions, right? This is actually a really, really similar problem. The only difference is that they gave us slightly different information to start with. But same kind of idea. If we know that z plus 2 minus 2i is one factor, what is another factor that we know about? And definitely pause the video and I'll think about that. Make sure you know what it is. You should have come up with the fact that z plus 2i is another factor, right? So now I'll multiply these two things together. Again, I'm going to use my trick of saying z plus 2 squared minus 4i squared. This is z squared plus 4z plus 4 minus 16i squared. That makes it z squared plus 4z. Oh, I'm sorry, I just tripped there for a second. That 16 there isn't supposed to be a 16. In fact, that wasn't supposed to be a 4. This was supposed to be a 2i, so that makes this a 4, and that makes this plus 8. There we go. Okay, so this is the factor. This was the factor we knew about. We got another one for free, and so this is the polynomial that I know has to divide into the thing that I have. So I could do polynomial long division here, but I want to do another sort of example of that sort of shortcut method so that you can see it. The idea is, again, that our polynomial 2z cubed plus 7z squared plus 12z minus 8 must be equal to z squared plus 4z plus 8 times something. And we just have to find that something. And in some cases, it's actually even easier. Like check this out real quick. In order for this to be 2z cubed, it has to be z squared. This, like, we don't even have a choice. That first thing has to be 2z. But then similarly, in order for the last term to be negative 8, I'm going to have positive 8 times, well, it's going to have to be negative 1. So in some sense, we know it's 2z minus 1. What you then should do is you should go through and sort of FOIL out the rest of it and make sure it really works. So just, check really quick. This here is 8z squared, and this here is minus 1z squared. That gives us the plus 7z squared we're supposed to have. These two things together are 16z. This is minus 4z. Good. That gives me the plus 12z that I was supposed to have. We're confirming this really does work. And the problem was asking, what are the solutions to q of z equals 0? Well, those are effectively the roots. So what were the three roots? Well, they started us off, if we go back up here, they started off by telling us that one of the factors was z plus 2 minus 2i. Z plus 2 minus 2i. Z plus 2 minus 2i. This was one of the factors, right? So the roots are going to be negative 2 plus 2i, negative 2 minus 2i because of the complex conjugate root theorem, and then the last one is this one, which provides us with a root of 1/2. These are the three roots of this polynomial. So the video was a little on the long side, but I wanted to make sure we had some good examples for you to work with.